Good evening, Professor. This is my personal timetable. So, first of all, I just want to tell you that in the last week I went Korea University for the electrochemical measurement, and I did the 10 P6 chip for the electrochemical deposition measurement, and I have used the graphene oxide for the deposition onto our P6 chip. So this is my table of content that is already explained you before, but for this personal timetable I just summarize in a short way. So first of all, I just want to describe the detailed chip functionalization that I already made by myself, and then electrochemical deposition, and further explain about the mechanism, what mechanism we are using, and what mechanism we have make it, and then fabrication process step, and also discuss about the P6 fabrication results until now, the new one, and also the previous one also in this content, and the future plan, and what are the different kind of electrochemical machine that we are normally researcher use, and why we are preferring the electrochemical method. So this is the future plan that I'm using P6 chip. So all the things are same that we already discussed before, but I just summarize in a short way. In the first, like the piranha cleaning with using the sulfuric acid and hydrogen peroxide 1:1 ratio, and then afterwards washing with the DI and ethanol. It's a series kind of washing. So first of all, we have to wash with DI and the ethanol, and then this third step that I already explained, that I went to Korea University for the electrolytic deposition. So in this step I have to use the electrochemical machine for the deposition of graphene oxide, and I have done with the 20 cycles, and I know it's a thick deposition of graphene oxide, and then afterwards I have to wash with the ethanol, or we call ethyl alcohol, and then afterwards I immobilize the EDCNHS. Until today I just immobilize EDCNHS and wash with the ethanol and then we mobilize antibody onto the surface using the 5 microliter or like 6 microliter, depend on the surface area how much we have, and then I use BSA and washing with the PBS, and then antigen, and then wash with the PBS. In the series, in this all step we have to measure the capacitance value, so that we can compare like is our capacitance value increasing or not. It depends on the concentration of the antigen also. So it goes on, and so this is the schematic representation of all steps. So as per your given comment by today morning and today meeting, so I have to just make the down what we call less thickness of the graphene oxide, that is the fully, but as per your given comment I just make the thin layer of the graphene oxide in between the electrodes, and then simultaneously I just all the things will be getting down because of the graphene oxide on thickness. And this is the whole step that I have followed until the washing with the PBS. And so this is the electrochemical deposition system, that this is the place where we use this kind of scenario. Like we have 3 different kind of electrodes. First is the counter one, is the platinum, and the second one is the working electrode, and third one is the reference. So we called as a reference electrode. It's a AG and AgCl electrode. So this chip I used is I did the last week 10 P6 chip, and this solution I used as a electrocatalytic probe, and this are the 10 chips that I did with this machine. So it looks like the linear or like thin, ultra thin film of the graphene oxide, and is much more stronger than the spin coating and the dip coating. So that's why I'm preferring for this one. And it's a clear picture of the all the electrodes. So as I already mentioned that this one AGCL is a reference electrode and PT is a counter, and our P chip is deep into the solution. Solution is the graphene oxide, so it's like our chip acting like a working electrode. And this is the updated results until today, and tomorrow I will go to measure with the ADC NHS, and then antibody and antigen is a series of the calculating results by using the impedance analyzer in terms of capacitance. Until now the value is in picofarad, and this is the chip fabrication step. First we have to use the prena cleaning. After cleaning then we have to use the DI water and then ethanol until this one OH bond is fully functionalized over the surface, and then graphene oxide solution is fabricated onto this electrochemical deposition method. So in this way, so I have to make this one, and our measurement criteria is like scan rate, this one number of cycle is like 20, and then maximum current and maximum voltage, and frequency is from 1 megahertz to the 10 microhertz. And afterwards the annealing process that I already did in the Korea University after the deposition of the graphene oxide. So it's like we have to put onto the hot plate until at 80 degrees Celsius, so that the carboxylic bond is activated onto surface, and afterwards ethanol washing. They have to drop cast EDCNHS. It takes 30 minutes for drying, but it's amide bond formation after that, this antibody immobilization, and the hydrogen bond also form onto the surface to bind with the BSA, and then afterward BSA. It's like antigen immobilization. It does not take more than 10 seconds to bind with the antibody and antigen. It's a very fast, ultra fast mechanism going is ahead, like to bind with the antibody and antigen complex to make a non-covalent bonds and electrostatic bonds activated. And after this combination with the two complex and then washing with the PBS is a drop by drop method, and then we have to calculate our capacitance value in terms of this in terms of the nanofarad, and the whole process summarized in terms of the time limit, how much time limit we have to measure. So it's approximately, it's a tentative, it's not finalized, but if we can measure in this scenario, then we have to complete this whole process in 90 or like 80 minutes, not more than that. But until today I just have to just finish up to the ADC NHS, and then tomorrow I have to continue with the whole process, and on Wednesday I will throughout them come with the results until the last stage. And I already mentioned the previous result of electrochemical deposition on D5 and P6 chips. So this is the whole process, and the same thing that I already explained before, so I just want to skip that one. And then this one is the result of the previous electrochemical deposition deposited chips, but in this chip I have to conclude that the value is not stable up to the antibody because of the very thin layer deposition, because I have run the 10 cycles on this chip. So that's why I use now 20 cycles in each chip, and it takes 25 to 28 minutes. So I hope so it's we getting the positive results. And in terms of the nanofarad, because in this results the value is in the nano picofarad, so I was surprised, like is it maybe because of the thin layer deposition of the graphene onto the surface. So that's why I just used the 20 cycles, and hopefully we will get the positive results of the updated one. And D5 is not suitable for the electrochemical deposition because of the surface area, and the active part is not equally contributed with the solution like electrocatalytic probe. So that's why I just focus on to only the P6, not on the D5. And this is the another method that some researchers followed, that it's the same case for ours, like we just use this kind of scenario, and but we have to just think about until antigen formation, not we have to put the again antibody. And this one is another paper that is related to the Journal of Hazardous Material. The researcher used the same kind of interdigitated electrode, but they use electrochemical method for the whole process, and they just used to define that the deposition of polypyrrole on the surface of the electrocatalytic interdigital electrode, and then dipped into the chemical resistor in the electrolyte, and the exposure of the polypyrrole film to the target in the presence of potassium chloride and a ferriferrocyanide. So it's detection of the ammonia, and in terms of the electrochemical measurement. So this is the method that we have to, in future we have to work on it, and hopefully, and I'm pretty much sure there's now currently nowadays the people, the researcher using the three different kind of things in terms of point of care application. Like first is the electrochemical method, second one is like FET, is the field effective transistors applications, and the third one is like our case, if we have the large surface area or like large active part onto the chip, then we have to move forward into with the collaboration with the electrochemical measurement, and then we create the point of care application, much more efficient and more productive. And this is a various different kind of electrochemical machine that I already explained before, so I just want to skip that one without taking so much time. And this is the another machine that is related to the electrochemical measurement. So it's a very advanced and it's very cheap. It can be done at the lower temperature as well. And why I are preferring the electrochemical method? Because it's not so much complicated, and it's also applicable on the only on the conductive layer, electroconnection to the wafer, like our substrate, and it related with the voltage, temperature, current, and resistance, and the reproducibility and good uniformity, and like our main goal is to deposit the graphene oxide in the whole chip linearly, uniformly. So this is the method that we have to tackle this point, and it's transfer patterns that run in and across cavities. Metal patterning also preferable for this method. So I hope so, and we will get the better results as compared to the spin coating and spray coating or like drop casting. That's all, sir.